Welcome back, and let's continue with our momentum. Now we are in the part of impulse and change in momentum. We learned about change in momentum, which is delta P. Now the impulse. To understand this one, we are going to use what we know already, which is Newton's second law. We did in grade 11. Newton's second law is defined as this by this formula of F net equals to ma. If we expand this, we'll find that acceleration is defined as the rate of change of velocity. Now, if we cross multiply, we'll end up with F net delta T equals to m delta V. Therefore, remember, m delta V will be the same as your m into Vf minus Vi. If you remember the change in momentum, that is this represents the change in momentum. That's change in momentum, change in momentum, and therefore the other side will be the impulse. That's what we call the impulse, meaning that the impulse, if you want to define it, remember momentum we said is the product of mass of an object and its velocity. Therefore impulse, you're going to define it using this. Therefore the impulse will become now the product definition, product of the net force, F net force, in this case acting on an object, and the time it takes while acting, the time that the net force is in contact with the object, in contact with the object. So impulse becomes the product of a net force acting on an object, which is your F net, and the time delta T it takes while acting, or the time that the net force is in contact with the object. That will be the definition of impulse. And then in terms of measurements, because you say impulse equals to, if the impulse equals to F net delta T, therefore it will be measured in Newton second. This Newton second is the same as just kilogram meters per second, meaning that whether you use Newton second or kilogram meters per second, your answer will be the same, correct? But don't forget both are vectors, then it will include also the direction. So take an example. In this case, they say if we have got this example of a cricket ball of mass 175 grams, is thrown, if it's thrown at 12 meters per second towards a player, a cricket player, in this case a player, it is hit and back in opposite direction. It hits back, it was heated, it hits back, and then in opposite direction, in this case at 30 meters per second from the cricket bat. And then now they say the ball is in contact the ball is in contact with the bat, with the cricket bat, with the bat for 0.05 seconds. Now comes the question to say calculate the impulse. Find the impulse. Find the impulse. Very easy. Remember, impulse, we can use impulse. In this case, they are twofold, mean that impulse is F net delta t. But if this is not given, we can use change in momentum, meaning that impulse will also be your mvf minus mvi. So the two are the same. So here we are not given F net and delta t, but we can now use change in momentum. We'll say impulse equals to mvf minus mvi. Therefore, in this case, we substitute. The mass is not in kilogram. We have to convert it to kilograms. 1, 2, 3, then becomes 0.175. The final velocity is, if we take towards the bed as positive, away from the bed will be negative, will be now multiplied by negative 30, and then 0.175 multiplied by positive 12. So it depends. You can either choose this one as positive, this one will be negative, because the two directions are opposite. Therefore, it will give us negative 7.35. Then, because this is a vector, therefore we know that it will be now 7.35 Newton second or kilogram meters per second to the left or away from the bed. To the left or away from the bed. I think that's how we calculate your impulse in this case. I hope it's understood. The next stop, they say to us in this case, can we calculate the force exerted by the bed? Yes. With the given information, we can do that. Calculate the force. Finding the force, then that one will be, we are using that formula of F net delta T equals to delta P. Already we found the impulse, that is negative 7.35. Therefore, it means that now F net, the time in contact is 0.05. This is negative 7.35. Therefore, F net will be negative, in this case, 147, because it's a vector. Then now we have to interpret the negative sign. Then it will be 147 newtons to the left or away from the bed. So the bed exerted a force of 147 to change the direction of the cricket ball. That's how we calculate the net force. Now the last question can just try to tap into your grade 11 knowledge to say, can you calculate the force that the bat exerts on the ball? So now the force of the bat, of the ball on the bat, ball on the bat. This was the force of the bat on the ball. Now we need the ball on the bat. Remember, there is what you call a Newton third law. If this is the bat and this is the ball. Now, if object A exerts a force on object B, the force of the ball on bat, it will be the same as the force of the bat on the ball. So that's Newton 3. Therefore, the two forces will be the same, that the force of the ball will be the same as 147, but the only thing that will be the direction will be to the right. That's the case. That's Newton 3. So you can just say that one and say the reason will be Newton's third law. I think we understand one another, so therefore the impulse won't be an issue. The moment they talk about the average force or the net force in this section of momentum, there is only one formula that should come to your mind. This is the formula, the one of impulse and change in momentum. So I think it's understood so far. We are moving on to the next step. Thank you.